One more, arranging atoms and ions by decreasing size. Let's take a look at oxygen and its anions. Here's a generic atom with 3 protons and 3 electrons. When you're adding electrons to a neutral atom or even an ion, every electron that you add is going to cause more repulsion to the electrons that are already there because electrons repel each other. That's going to cause the atom to puff up, and not only that, now you have more electrons sharing the same number of protons, so they'll be less attracted to the nucleus. So the more electrons you add, the larger the radius. So in decreasing size, we got the O2 oxide anion is larger, and then the 1 negative oxide, and then the neutral oxygen atom. Let's take a look at B. These are transition metals. Let me use a different color here so it stands out. Iron, well, that didn't help much. All right, iron, nickel, and zinc. When you remove electrons from transition metals, you're removing from the S's before the D's. So in other words, they all have electrons in their 3D, their valence electrons in the 3D. Oh, it tells you right there. Now, the main difference is, as you go to the right, there's more protons attracting those electrons. So all 3 of these are experiencing about the same level of shielding. So the main factor is the nuclear charge increasing as you go to the right. So as you have more protons, that's going to bring in the electrons closer. So they're going to get smaller as you add more protons. So the largest of this is going to be, it's just going to be right in that order. The iron 2 plus cation, followed by the nickel 2 plus cation. And the smallest is going to be the zinc 2 plus cation. And that's a general trend as you go left and to the right on the periodic table. The shielding remains relatively the same and the nuclear charge increases. So the radius decreases. Finally, C, we got calcium losing 2 electrons, and that's going to be isoelectronic with argon. Potassium losing 1 electron, so it's also going to have 18, and chlorine gaining 1. So we've seen this numerous times already. When you have 3 isoelectronic ions, the more protons, the one that has the most protons is going to be the smallest, because with the same number of electrons, you have more of the nuclear charge attracting those electrons. So the largest is going to be the one that has the fewest protons, which is chlorine with 17. And the smallest one is going to be the calcium with the most number of protons, with 20.